You are falling. Not through air. Not through water. Through the fabric of space itself. Around you, the stars begin to bend. Light, the fastest thing in the known universe, is curving, warping, being pulled. And you realize, with a terror that lives somewhere deeper than fear, that you have just crossed a line you can never uncross. There is no alarm. No warning system. No wall, no barrier, no visible door. Just a point of no return. And you are already past it. Imagine for a moment that you are an astronaut. Alone. Drifting through the deep silence of space, somewhere beyond our solar system, somewhere in the outer arms of the Milky Way galaxy. Far ahead, you see nothing. Just blackness. A circle of absolute dark, ringed by a halo of fire, light itself being dragged into orbit like water circling a drain. This is a black hole. Not a theory. Not a Hollywood invention. A real object. A real place in our universe. And right now, it is pulling you toward it at speeds your mind cannot process. You have about 11 minutes before you cross the event horizon. 11 minutes to understand what is about to happen to you. To your body. To time itself. This is not science fiction. This is astrophysics. And it is far more terrifying than anything fiction could invent. Let us start at the beginning. A black hole is born from death. Specifically, the death of a massive star, something at least 20 to 30 times more massive than our own Sunday. When that star runs out of fuel, it can no longer sustain the nuclear fire that pushes outward against gravity. And so, in a fraction of a second, gravity wins. The star collapses inward. The outer layers explode outward in a supernova, one of the most violent events in the universe. But the core keeps collapsing. Past the density of rock. Past the density of an atomic nucleus. Past any state of matter we have a name for. It collapses into a singularity. A singularity is a point in space where our understanding of physics completely breaks down. Infinite density. Infinite gravity. A place where Einstein's equations of general relativity return an answer that makes no physical sense, and yet, they return it every time. Around that singularity is the event horizon. This is the true edge of the black hole. Not a physical surface. Not a wall you can touch. It is simply the boundary beyond which the escape velocity, the speed you would need to fly away, exceeds the speed of light. And nothing in this universe travels faster than light. Nothing. Which means that once you cross the event horizon, you are not simply trapped. You are mathematically, physically, cosmically forbidden from ever leaving. The universe itself has closed the door. But here is where it gets truly strange. Here is where space and time stop behaving the way your brain expects them to. Albert Einstein changed everything in 1915 when he published his theory of general relativity. He told us that gravity is not a force, not the way Newton described it. Gravity is a curvature of space-time. Mass bends the fabric of reality. And the more mass concentrated in one place, the more extreme that curvature becomes. Near a black hole, that curvature becomes so extreme that space-time itself is being dragged inward, like a river accelerating toward a waterfall. Even light, traveling at 300,000 kilometers per second, cannot swim upstream fast enough. It gets carried over the edge. Now here is where it gets personal. As you fall toward the event horizon, something called gravitational time dilation begins to take effect. Time, the thing you have always trusted to move forward steadily, reliably, 1 second per second, begins to slow down. Not metaphorically. Physically. Einstein proved that the stronger the gravitational field, the slower time passes. This has been measured. It is real. Atomic clocks on the International Space Station tick at a slightly different rate than clocks on Earth because of this exact effect. GPS satellites have to correct for it constantly, or your navigation would drift by kilometers every single day. Near a black hole, this effect is not subtle. It is catastrophic. From the perspective of someone watching you fall from a safe distance, let us say, a rescue ship hovering far away, they would see you slow down as you approach the event horizon. Your movements would become sluggish. Your radio transmissions would stretch out, their frequency dropping lower and lower, redshifting into silence. You would appear to freeze. A statue of a person, hovering at the edge of forever. They would watch you fade into red, then infrared, then nothing. You would appear to never actually cross. But from your perspective, from inside your falling body, you would feel no such thing. You would cross the event horizon in a moment. Possibly without even realizing it had happened. There is no sign. No flash of light. No alarm. Just the stars above you, now compressed into a single bright ring, a phenomenon called a photon sphere, and below you, absolute nothing. You are inside now. And time, for you, is running out in a way no clock was ever designed to measure. Let us follow you in. Let us be honest about what happens to a human body inside a black hole. As you fall deeper, the tidal forces begin. Tidal forces are simply the difference in gravity between 2 points. On Earth, the Moon pulls slightly harder on the side of the Earth facing it, and slightly softer on the far side. That difference is small enough to merely raise our oceans. Near a stellar mass black hole, the difference between the gravity at your feet and the gravity at your head would be measured not in millimeters of water, but in millions of tons of force. Your body would begin to stretch. Feet first, assuming you fell feet down. Your lower half would be pulled faster than your upper half. You would feel yourself elongating. The sensation would start as pressure. Then pain beyond description. Then your body would begin to pull apart at a molecular level. Scientists call this process spaghettification. That word sounds almost comical. It is not. It is perhaps the most violent transformation a collection of atoms can undergo, stretched into a thin stream of superheated particles, spiraling downward toward the singularity. You would not survive to reach it. But if you could, if somehow consciousness persisted, if somehow you fell into a supermassive black hole like the one at the center of our galaxy, Sagittarius A*, which is 4 million times the mass of our Sun, the tidal forces at its event horizon would be gentle enough that you might cross without immediate destruction. And then you would look up, and you would see the entire history of the universe. Because of the extreme time dilation you are experiencing, time outside the black hole is passing faster and faster relative to you. Looking outward through the event horizon, you would theoretically see billions of years of cosmic evolution compressed into the last moments of your fall. Stars being born, burning, dying, galaxies colliding, the universe expanding around you like a time-lapse of creation itself. Then the light would fade, and there would be nothing left but the singularity below you, and a darkness so complete it has never been given a name. But here is where the universe whispers something no physicist can fully explain. What happens to you, to the information that makes you you, inside a black hole? In 1974, Stephen Hawking made a discovery that shook the foundations of physics. Black holes, he said, are not perfectly black. They slowly radiate energy, what we now call Hawking radiation, and over an incomprehensibly vast span of time, they evaporate, shrink, and eventually disappear. But if the black hole disappears, what happens to everything it swallowed? Quantum mechanics says information cannot be destroyed. It is one of the most fundamental laws of physics. But general relativity says once something crosses the event horizon, it is gone forever. These two pillars of modern physics, the two greatest frameworks humanity has ever built to understand reality, directly contradict each other inside a black hole. This is the black hole information paradox. And after 50 years, it remains unsolved. Some theorists believe the information is encoded in Hawking radiation, scrambled beyond recognition but technically preserved. Others believe it is stored on the surface of the event horizon, like a two-dimensional hologram of a three-dimensional reality. Others, and this is where it becomes genuinely unsettling, believe that the singularity is not an ending at all. That it is a doorway, a bridge to another region of space-time. Perhaps another universe entirely. Perhaps falling into a black hole is not death. Perhaps it is arrival. We have sent rovers to Mars. We have photographed the surfaces of distant moons. We have even captured the first real image of a black hole, Messier 87, a supermassive black hole 55 million light-years away, photographed by the Event Horizon Telescope in 2019. A blurry orange ring of fire, surrounding an absence so profound it silenced rooms full of scientists when they first saw it. But we have never sent anything across the event horizon and received an answer back. We never will. The black hole keeps its secrets absolutely. Every atom that has ever fallen in, every star, every planet, every particle of ancient light, is held there, silent, beyond our reach, beyond our equations, beyond our understanding. And perhaps that is the most terrifying truth of all. Not that the universe is violent. Not that it is vast. But that it contains places where our knowledge simply stops. Where the laws we have spent centuries building break apart like paper in a storm. We stand at the edge of our understanding and we look out into the dark, and the dark does not explain itself. It simply waits. If this journey into the unknown left you breathless, hit that subscribe button, because we are just getting started. The universe has secrets far stranger than this one. And we will find them. Together. The universe is not obligated to make sense to us. It only has to exist. And somehow, impossibly, it does.